Okay, so we've tried 0, 1, and minus 1. And we found that 0 and minus 1 were part of the Mandelbrot set. What do these three numbers have in common?
Well, they're all pretty close to 0.
That's true.
They're all in our complex plane, they're all on one axis.
And what is the name of that axis?
They're real axis.
These are real numbers.
Real numbers.
But I told you that the Mandelbrot set was in the complex plane. So why don't you tell me a complex number that we could test?
So like maybe a complex number
An imaginary number.
I?
I. Okay. Let's see. Now, before we try it, what do you think? Do you think I is in the Mandelbrot set, or I is not in the Mandelbrot set?
Yeah, I think it is in the Mandelbrot
Yeah.
set.
Okay, you think it will be. You think I is in the Mandelbrot set.
Mm-hmm.
Do you think I am in the Mandelbrot set?
Ha 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 ha. No.
Okay, so what happens when I square I?
So
You
you
get
get minus one. Minus 1 plus.
Okay, so I start with I. Here we're going to have to keep track of the numbers because it might get a little bit more complicated. So I start at I, and then I go minus 1 plus I.
Minus 1 plus I. And you have to square that.
Okay. Now I have to square minus 1 plus I.
So.
Okay.
Well, you'd get 1.
Minus 1 plus I times minus 1 plus I. So how do we even do this multiplication? Do you know?
We have to do minus 1 times minus 1 times I times minus 1, and I times I.
Okay, very good. So minus 1 times minus 1 is
1.
1. Minus 1 times I is
Minus I.
minus I.
And then another minus I.
Another minus I.
And then minus 1.
Minus 1. And then I have to add I on at the end.
Well,
So that would cancel out a minus.
So I get a 1 and a minus 1 canceling out.
and the I and the minus I cancel out.
And I get minus 2I plus I. So
Minus I.
minus I. That's interesting. Okay. Now, but I have to plug minus I back into here now.
Well, and that's gonna get I minus I squared is gonna be minus 1 still.
Okay, minus 1 plus I.
Plus I.
Okay, so what's going to happen here?
It loops.
Yeah, actually, this one's interesting because it starts looping in a different direction. It doesn't go back to the original number.
It just goes looping from here.
It
So
loops
this
from
one is in the Mandelbrot set.
That's right, I is in the Mandelbrot set. Do you think minus I is?
We could see something similar here.
Now, what do you think will happen when you do minus I?
Well, maybe we'll get minus I, then 1 minus I, like the inverse of this. So you would get minus I, 1 minus I, and then 1 minus I.
All right, well, let's just see what happens. Let's see. Do you think, since I is in, do you think minus I will be in?
Yeah.
Yes.
Okay, so let's just start. We start at minus I. Minus I squared is?
Minus 1.
Minus 1. So minus 1 minus I. That's our next number. I suppose I could have written that slightly better in column. Minus 1 minus I. All right, so what is minus 1 minus I squared? What do we do there?
So we can do the same thing.
Minus.
So we get 1.
1.
1.
And plus 2I.
Well, let's just go
It's
slow. Minus
plus-
1 times minus I. So plus I.
Plus I.
Plus I there.
And then
Minus I
Minus.
times minus I.
so minus 1.
Minus 1. And then I have to do a minus I.
So we get an I.
Then we get back to I.
And then we would get
Minus 1 minus I.
Minus
Again.
1 minus 1 minus I.
So it loops in the same way.
So it loops in a very similar
So
way.
I and minus I are both on.
Okay, cool. So we found a couple numbers that are in. And so if we were making a graph or a plot of the Mandelbrot set, we would have found, so far, we've looked at 5 numbers. Minus 1 was in. And maybe we would color that
And 0.
somehow.
0
Do you have
is.
a different color marker around?
um,
it's okay. I even have a better idea. I'm going to make snap cubes.
We have.
Give me the green ones for not in.
Uh,
Okay, so -1 was in. We're going to represent that with an orange snap cube. Here's I up here. Here's -I. Here's 0. And here's 1.
So all of these but 1 were in.
Okay.
1 was not in, and
All
then
right.
the rest were.
So if we were going to make a plot coloring the points that were in orange and the points that were not in green, this is our first basic plot of the Mandelbrot set. And so what do you think would help us make a better plot?
Well,
If
more
we
points.
tested more numbers.
Yeah, okay, we tested more
Like-
numbers.
Like more difficult numbers. Like, what about here, for example,
Yeah.
or up here?
Yeah. Well, well, yeah, you're right. That's exactly. And by the way, you also noticed. I forgot. You noticed that anything over this way would go to infinity. So we know that these are not in.
So
Over
just
here.
past here.
Yeah. Well, only on the real end. We don't know. Like maybe this point up here is in. And it gets a little bit more complicated too because it's not so easy to know if something's going to infinity. Like maybe, like for one, it was easy because it just shot off to infinity.
Yeah.
But maybe sometimes things wiggle around and you don't quite know where they're going. So what you have to make some decisions if you're writing a computer program.
If they get past 1 in the real number, then they would go to infinity.
That's a great observation. If they ever landed over here, you would know it would go to infinity. So what they do is exactly something very similar. They know that the Mandelbrot set can be contained inside of a big circle. Let's say that circle, maybe it's radius 2. And so they say something similar. If you ever land in a point that's outside of the circle of radius 2, you know you go off to infinity. So that's what they keep track of as you're iterating. And you say, well, I'm going to maybe try 10,000 iterations, or 500, or 100. And if I ever get outside of the circle, I'll say it's not in. If it never goes outside, I'll say it's in. But you don't know for sure, right? Because how many iterations do you have to do to make sure something has gone to infinity?
Well, infinity.
Yeah, and so how long will that take on a really fast computer?
Pretty long time.
Forever, yeah. So you have to make some decisions to kind of shorten it up. But what I'm going to show you now is playing around with it on Mathematica, because they have a cool Mandelbrot program.
Okay.